we're going to look at increasing, decreasing from sine diagrams, and it's where sine diagrams of first derivatives. So the question is 3b, question 7. Find intervals where the function is increasing or decreasing. The method is we actually find where the gradient is positive or negative. Right, so we find the first derivative, our gradient function. If that's giving us positive answers, we are increasing because we've got positive gradient, we're going uphill, the function is increasing. And I got asked about C, D and F. I'll do C and D in this video, I think. I think C doesn't look too bad, but maybe D. D has an asymptote in it. X can't equal 1. And that will need to go on the sine diagram, so that's a good one to look at. Okay, let's 7C. 7C. So it's exercise 3b, question 7c. The function was, yeah, that's right. I have very little, was it 3x squared plus 1. 3x squared plus 1. There was no way I was going to remember that. All right, derivative is chain rule, inside, outside. So the outside, 4 goes there, and then you minus 1 off the 4, you keep the inside the same. 4, 3x squared plus 1. Then you look at the inside, what's the derivative of the inside? It's 6x. Tidy it up maybe. You could say you've got 24x, 3x squared plus 1. You can apply null factor law to this. Yeah. Because if a, b equals 0, then either a0 or b0. Hence, we can find out where does this function equal 0, which is one we want to put in our sine diagram because it's about those points where you'll have negatives and positives. So, finding the stationary points for the sine diagram, I would say when x equals 0, now that part's easy, that's coming from here. If x equals 0, everything equals 0. When this bit in here, I don't care if it's cubed or not, if that's equal to 0, 3x squared plus 1 equals 0. Now the answer is going to be never, because it doesn't matter what x you put in, you're going to square it. If you square a negative number, you get a positive number. Everything else is positive. Let's just go through the algebra. You'll get minus 1 from both sides. Then you have to divide by 3. You'll get x equaling plus or minus the square root of, no solution, right? But that's okay. There's just one stationary point. It's a quartic. Maybe you know that your most basic quartic basically looks like the letter U. Kind of a bit flatter around there than a quadratic. So if I'm looking at that, it's decreasing until I get to x is 0, then it's increasing. This one looks similar, right? So I'm not, not overly surprised about that. Now to draw the sine diagram though, make sure you label it, right? Because your sine diagram is of your derivative. You can do sine diagrams of all sorts of things. We want the derivative. We want to put on the stationary point, 0. We want to test on either side. So let's test minus 1. If I put in a minus 1 here, I have negative 24. Whereas it doesn't matter what I put in here, it'll be positive because minus 1 squared will be positive. So that's negative and that's positive, right? If you put in the number 1, if you're testing this region, 24 times 4 cubed, whatever that is, it's a positive number, right? So you are done. If you were having to classify the stationary point, right? I mean, I'd probably draw this in actually. I'm going negative gradient, positive gradient. I've got a local min. Just be aware that you need to be finding out where that point is on the function, right? If I'm classifying, I'm not saying what the gradient is there. I mean, the gradient's 0. I'm saying where is this actual point? So I go back to the function, I put my 0 in, I would get 1 to the power of 4, which is 1, right? I don't think the question asked for that, but you may have questions that do. All right, so it was C, D, and F. Let's look at D. Okay. Maybe a bit harder, this one. F of x squared plus 4 on x minus 1. X squared plus 4 on x minus 1. X squared plus 4. X squared, you can do it memory. X squared plus 4 on x minus 1. Right. So I would probably rewrite it. So it follows that the function could be written as an x squared plus a 4 times x minus 1 to the power of negative 1. And I think that will make finding the first derivative a little easier. I will get what? 2x. And then this part of the derivative will need chain rule. So minus 4, x minus 1 to the minus 2. That's the outside. The inside is just 1. So that's finished. And to tidy it up, I could say the first derivative is a 2x minus a 4 on x minus 1 squared. Okie dokie. If I want to find when this equals 0, we could say equals 0 when minus 4x, minus 4 on x minus 1 squared equals minus 2x. Or you could use a common denominator. You could say, let's put the whole thing on x minus 1 squared. We have to times that by x minus 1 squared minus 4. Right, so I'm giving this term here the denominator x minus 1 squared, so I have to times the top by that as well. And I would get 2x, x squared minus 2x plus 1 minus 4 on, let's just call that v. Maybe even d for denominator. It's a bit clunky writing with this pen. 2x. What am I trying to do? Expand. 2x cubed minus 4x squared plus 2x minus 4 on a denominator. When does that equal 0? You could say it equals 0 when x cubed minus 2x squared plus x minus 2 equals 0. So what I did there was I dropped the denominator because if the numerator is 0, the whole thing's 0. And I divided everything by 2. Once this equals 0, we can divide by a constant both sides and simplify things. Now for something like this, you could try out a few numbers to see if they work. And I think the answer was 2 works. But if not, you go to the calculator, right? By the way, this way is easier. I'm just thinking that a lot of you probably used x minus 1 squared as a denominator and did it this way, and it should work either way, right? What I've done here on this side, I've said that equation there, when does it equal 0? Maybe I'm skipping a step. I'm saying 2x minus 4 on x minus 1 squared equals 0. So I'm minusing 2x from either. No, let's add. Yeah, so 2x, then we're going to add this term to both sides. It's 4 on x minus 1 squared. We times both sides. What's x minus 1 expanded? Minus equals 4. Notice what's happening. We've ended up in the same place, right? 2x, then we got the minus 4, that equals 0. Divide everything by 2, I'm here again, right? So, bit of work, I'm going to make some room, maybe here. Now, if I plug a 2 in, I'll get a 0, and that's the solution, and it would help me to start factorizing, but let's pretend I didn't know that. I would do this. I'd go to the calculator, and you'll see that I've done this. Oh, hang on. Let's simplify it, sorry. Divide by 2, x cubed minus 2x squared. I had this up before, and I've just erased it. Minus 2 equals 0. Right. So we go calculator time. You need to be pressing apps. Actually, it's going to help if I blank the screen. You go apps. Where's apps? There. Well, I'm already in there. Let's quit, just in case you are not familiar. You go to polysmalt2. You choose a root finder. We have a cubic, so the order needs to be at 3 for cubic. Then next. So we need to change. I'm putting in 1 minus 2 plus 1 minus 2. Those are the values I have to actually put in. Let's double check it actually. I've got a 1, a minus 2, a 1, a minus 2. Is that what I've got here? A 1, a minus 2, a 1, a minus 2. And then I'm going to solve. And it says here, it's a bit hard to see, but it says x equals 2. And it's only given one solution. Right. So the calculator's found it for me, right? There's only one solution. From that, you can go straight to sign diagram. But if you like, you can use the solution to factorize. If you put a 2 in there, if x equals 2 and you get a 0, you could write that as a linear factor with an x minus 2. Yeah. Because it will have to fit this null factor situation. If x equals 2, that's all 0, right? Times it by whatever that is. Yeah. So you can use the 2 to factorize. I think some of you will be comfortable with that. I'm trying to make this polynomial here. I know how this quadratic bit starts and how it finishes pretty easy, because x times x squared, that's giving me this. That's giving me the x cubed. Minus 2, I'm thinking, what does it have to multiply by to give that minus 2? Well, it has to be 1, all right? But is there an x term in here? Not sure. I need to make a 1x. Where would that come from? I've already got 1x. So I think that's a 0. Because if I do x times 1, I've got my 1x here. I don't want to have to come along and do minus 2 times some other x. What about I'm going back and forward, it's not laid out. What about this minus 2x squared? Is that working here? You'd have to do minus 2. Yeah, we've already got it, right? Minus 2 times x squared. There's the minus 2x squared I wanted. And then here, x times 0, x squared. Like, that's nothing, it's 0. So what we've actually got is x minus 2, x squared plus 1 equals 0. This has no solutions, right? There's no way to square a number, add 1, and have 0. So on the sign diagram, there is just the 2 as a stationary point. However, there's also an asymptote, right? And hopefully you see that before you even start. So you see this denominator in the function, right? By the way, it's in the derivative as well. So you can see it in the derivative. X cannot equal 1. And before you even start, you could be thinking about that. And that needs to go on your sign diagram as well. Right, so labels, x's. We've got a 2 and a 1. I'll just put on the 1, the 2. Now with the asymptote, you can label it like this. Right? I think the easiest, where's the easiest version of the derivative for me to test? I reckon it's probably that one. Right, so kind of like there, except just not equal to 0. So I'm going to be testing values. I think it's easier to see when you write fractions. So if I go for a number smaller than 1, minus 2, what would happen? I'd get minus 4 here. That would be positive. So I'd get minus again, I'd have negative. Right, so you're going downhill to an asymptote, it would be like that. Let's put a 0 in. So in this, I should have put 0 in there. That was silly. Would have been easier just to test a 0. I put a 0 in. I would have had minus 4. It would have been negative. Yeah. When you're doing tests, if it's possible to test with a 0, do that. Make your life easier. I'm going to have to test 1.5. See how we go with that. So 2 times 1.5 is 3 minus 4. Okay, 1.5 minus 1 is a half. A half squared is a quarter. So I've got 4. How many quarters? That's 16. Isn't it? 4 divide 16, same as 4 times 4. So you end up with 3 minus 16. So you're negative. And you want to, there's your negative coming off the asymptote. Then at 2, I presume you've got a minimum. You're coming down, got a stationary point. So maybe if we test a 3, you might want to be showing yourself doing this. You could say the derivative when x equals 3 is, now you don't have to write the answer, you just need to write if it's positive or negative. So If I put a 3 in, I'd have a 6 minus 4 divide 4, because if x is 3, that's a 2. 2 squared is 4, that's a 1. So I end up with a positive number, right? You can show yourself doing these little tests for your sign diagram. You should probably draw that. If you need to classify, I could say local min at x is 2. I need to go back to the original function. It's up here, 2 squared. So because what's happening here, we're putting in f of 2. Don't write this, it's cheating. You need the actual number. So 2 squared is 4. 4 plus 4 is 8. Right? Now maybe think, that's a bit odd. A minimum when x is 8. Let's just actually go to Desmos and check this. In a test, you'd need to use your calculator. Maybe I should do it how you'd have to do it. X squared plus 4 divide x minus 1. Right, x squared plus 4 divide x minus 1. X squared plus, well, there's the other function from that other question we did. Okay, that's clear. X squared plus 4 divide brackets x minus 1. And then maybe just try a standard, but if we've got a minimum at 8, oh, there it is. So like it just fits on. We should be seeing, this is I'm doing this just to make sure you're comfortable with changing your window, basically. We should be seeing the asymptote at x is 1, right? So that line should be there, and I should be seeing a minimum here at 2 and 8. So if I did a second calc, min, left bound, whatever, right bound, ooh, guess, ooh, that's odd. It made it 1.9999999. Anyway, that's 2 and that's an 8. I wonder if that's in the scale it's using. Not sure. I'm not sure why that didn't say exactly 2, but I think you'd be okay with that x being a 2 there and not a 1.9999999. All right, well that'll do for this video. Thank you for watching. We did cover a few things there. So this function here only had the one stationary point. You've got to be on the lookout for when you're squaring, because you're going to get positives. This function here, we had an asymptote. We have to remember to put that on our sign diagrams for first derivative. Otherwise, I think it was fairly standard. All right, thank you.